Have you ever heard that two things are connected and it just doesn't quite add up? We're constantly bombarded with data telling us that this is linked to that. But how often is that connection real and how often is it just an illusion? Well, today we're going to pull back the curtain and unmask the truth hidden in the data. You're going to learn the critical difference between a real cause and a random coincidence and how to spot it from a mile away.
Okay, let's just jump right in with a really weird one. It is a statistical fact that when ice cream sales go up, so does the rate of violent crime. Seriously, I'm not making this up. The data shows these two things move together in a shockingly predictable pattern. So, looking at that, you have to ask the ridiculous question, right? Does a scoop of vanilla lead to a life of crime? Of course not. Our gut feeling, our intuition, just screams, no way. But the data by itself, well, it presents a real puzzle. If it's not the ice cream, what in the world is the hidden connection? That's the mystery we're about to solve.
All right, cracking this case comes down to understanding one of the most important ideas in all of science and statistics: the difference between correlation and causation. It's a simple idea, but it's so powerful. Just because two things are moving together, it absolutely doesn't mean one is the trigger for the other.
So let's break this down. On one side, you've got correlation. Think of this as just an observation. Hey, when this goes up, that goes up too. They're moving together. But causation? Oh, that's a whole different ballgame. That's a direct push. That means one thing literally makes the other thing happen. Yeah, correlation is just noticing a pattern. Causation is pointing the finger and saying, you did this.
So, when our spidey sense is tingling, when we see a correlation that just feels off, it's time to put on our detective hats. Because it turns out there are usually three main suspects, three hidden culprits that create this illusion. So let's go unmask them.
All right, culprit number one. This is the big one, probably the most common one you'll ever see. It's called the third variable problem. The best way to think about it is like there's a hidden puppet master. You're watching two puppets on a stage, and they seem to be interacting, right? But really, there's someone behind the curtain pulling both of their strings.
And ding, ding. This is exactly how we solve our ice cream mystery. The hidden puppet master, the third variable, it's hot weather. Think about it, right? As the temperature rises, of course, more people buy ice cream. But at the same time, more people are outdoors, tempers can get a little shorter, and unfortunately, crime rates also tend to tick up. The heat is driving both trends completely independently. The ice cream had nothing to do with it.
Okay, on to our second hidden culprit. This is the classic what came first, the chicken or the egg problem. We call it the directionality problem. It's when you know, you're pretty sure, two things are connected, but you just have no idea which one is causing the other. The arrow of causation could be pointing left, or it could be pointing right.
And here's a perfect medical example. We know for a fact there's a correlation between low levels of vitamin D and depression. But which way does the arrow point? Does the lack of vitamin D actually contribute to causing depression? Or is it that when people are depressed, they tend to stay inside more, not get enough sun, and that's what causes the vitamin D deficiency? Without more research, it's just impossible to know for sure. And that leads us to our final culprit, which is kind of a cousin of the directionality problem. This is called reverse causation. This is when you're not just unsure, you're sure, but you're dead wrong. It's when you confidently draw that arrow of causation, but you've pointed it in the completely wrong direction.
This is a really powerful example of why getting the direction right is so critical. It's easy to assume that poor health might lead to job loss and then poverty. But the research often shows the exact opposite is true, that poverty, with its lack of access to good nutrition and healthcare, is a powerful cause of poor health. And you can see how getting that arrow backward has massive implications for how we even try to solve a problem like that.
Okay, so we've seen all the pitfalls and the ways our brains can be tricked. So how do researchers get it right? How do they go from, these two things seem related, to, yep, this definitely causes that? Well, let me tell you, it is not easy. They have to follow a very strict checklist to move beyond just a simple correlation.
And here's that checklist. First, the cause has to happen before the effect. I mean, that just makes sense, right? Second, the two things do actually have to be related in the data. And third, and this is the big one, you have to rule out all other plausible explanations. You have to go on that detective hunt and eliminate every single possible third variable. And to do that, the absolute gold standard for proving causation is a type of study called a randomized controlled trial.
So why does all this matter to you and me in our daily lives? Because honestly, understanding this difference is a critical thinking superpower. It changes how you read the news about a new diet or a financial trend or a medical study. It is the tool you need to separate the real information from all the hype.
You know, one of our sources for this explainer put it perfectly. It said that even in a field as rigorous as medicine, journals publish correlational findings all the time. It takes the careful judgment of an actual doctor to look at that and avoid jumping to a causal conclusion that could mislead them and lead to the wrong treatment. I mean, the stakes just couldn't be any higher.
So I'm going to leave you with this question. The next time you're scrolling and you see one of those headlines that says X is linked to Y, what's the first hidden culprit you're going to look for? Are you going to ask yourself, wait, could there be a third variable? Or maybe, are they sure they have the arrow pointing in the right direction? This kind of skepticism isn't about being negative. It's your superpower for becoming a smarter, more informed person in a world full of data.